Today we are going to study about Pert and CPM. What is Pert and CPM? You need to know what is Pert and CPM. These are just project management techniques. These are the techniques used in an industry to determine the time that would be required for the completion of a project. Uh, in a project, there might be various activities by combine and make events, and considering all those, what would be the maximum possible time that can be allotted to complete a project? We are going to study about some network diagrams, namely PART and CPM, which these two methods are going to determine how much time a project would take to complete. First of all, it is CPM, critical path method. It is a technique in which the activities are given more importance. The activities that take place in a project are given more importance. It is deterministic in nature. Deterministic in the sense it means that there is only one time available for one activity. Only one time is given. Basically it is used in non-research type, because only one time is given means you have to complete by that date itself. That is basically used in non-research type. Non-research type means you are able to know by what time you would be able to complete the project. And now moving towards part project evaluation review technique. It is a technique in which the events taking place are given more importance. Here the activities are not given importance. Here the event, combining those activities, a event would occur event, and that would be given more importance rather than those small activities. It is probabilistic and is used in research type problems. It is probabilistic means it has got three different times we use. That are the optimistic time, the most likely time, and the pessimistic time. We are going to discuss about these three times further on when we solve a problem. uh, Moving forward, if you want to write these points, you can kindly pause the video and write this. Now, what is critical path? Critical path is the maximum possible time taken for the completion of a project. It is the maximum possible time, and various activities would take various times. Considering all the activities, the maximum possible time that can be allotted or that is taken to complete a project is known as the critical path. Any delay in one activity in the critical path will delay the entire project completion. You might not get clear about this in like any delay in one activity in the critical path would delay the entire project completion. When I will show you the critical path, I will explain you how delay in even one of the activity in that critical path would delay the entire project. Here, what is critical path? Most of the students make a mistake in this. Like in GATE, you are asked what is the minimum time taken to complete a project, but you know that the critical path is the maximum possible time taken to complete a project. But you need to be clear that the minimum time taken to complete a project is also the critical path. I will show you how in the further slides. Now let's understand the network diagram. First of all, from 1 to 2, event 1 to event 2, through activity A, it is taking 4 days. 2 to 4, it is taking 5 days. And 4 to 6, it is 7 days. In the same way, 1 to 3, it is 5 days. 3 to 5, it is 3 days. And 5 to 6, it is 6 days. The time is given in the red colored form. Okay. Then there are various activities A, C, E, B, D, F. Okay. To reach 1 to 6, there are two ways: 1, 2, 4, 6, and 1, 3, 5, and 6. First of all, let us consider 1 to 2. 1 at 1, it would be 0 because it is the starting time. Then 2 would be completed. Event 2 would be completed in 0 plus 4 is equal 4 days. Event 2 would be completed in 4 days. And event 4 would be completed in 4 plus 5 is equal to 9 days. That is clearly given here. And event 6 would be completed in 9 plus 7 is equal to 16 days. But directly don't write 16 because there are two ways of reaching 6. One way is 1, 2, 4, 6, and other is 1, 3, 5 to 6. So you are not sure that would it be completed in 16 days or it would take some more time. Okay, for 1, 2, 4, 6 it is taking us 16 days. Write 16 and put a comma. Then we will see the part 1, 3, 5 and 6. From 1 to 3, 3 would be completed in 0 plus 5, 5 days. Even 5 would be completed in 5 plus 3 is equal to 8 days. And even 6 would be completed in 8 plus 6 is equal to 14 days. Now we are saying that there are two different times by which event 6 would be completed. One through part 1, 2, 4, 6 it is taking 16 days, and through part 1, 3, 5, 6 it is taking 14 days. Then there might be a question that which one would I write? It would be 16 days. 16 days is the answer, because without completing the activities associated in the part 1, 2, 4, 6, we cannot complete the entire project. We cannot complete the entire project without completing 1, 2, 4 and 6. 1, 2, 4 and 6 would be completed in 16 days. And we cannot finish the project keeping that 1, 2, 4 and 6 half done. Because 1, 3, 5 and 6 it will be completed in 14 days. But 1, 2, 4 and 6 is taking 16 days to complete. Definitely 1, 3, 5, 6 that part must wait 2 more days to get completed. That is the main concept behind it. And this part is known as the critical part. So the critical part is the part which takes minimum number of days or time to complete a project. Minimum number of time, but here it is, you will write the greater one. Greater digit among these two parts, but this is the minimum time taken. So in GATE there are question asked, you will be given a network diagram and they will ask you what is the minimum time taken to complete the project. So you don't write the 1, 3, 5, 6 because the project won't be completed before completion of 1, 2, 4 and 6. So the maximum, so first take out the critical part, then write that the project would complete in 16 days in this case. As in this case it is 16 days. So in here critical part is 1, 2, 4 and 6, and critical activities associated in this part are A, C and E. Okay. Kindly pause it and draw the complete diagram. Now how to construct a network diagram? You kindly pause the video and write this table in your copy. Okay. Okay, in this table it was 1 to 2 it take 2 days, 1 to 4 it took 3 days, 1 to 3 it took 4 days. These are given 1 to 2 2 days, 1 to 3 4 days, and 1 to 4 it is 3 days. Then 2 to 5 and 3 to 5, because at event 5 was preceded by both 2 and 3. So we will merge an arrow from both 3 and 2 towards 5. Now it is clearly seen that 5 is preceded by both 2 and 3. Then 4 to 6, 6 was preceded by 4, and hence the 6 is the final event. We will draw an arrow 5 to 6. Are you clear about it? You kindly draw the network diagram. Pause the video and draw the network diagram. Now TE1, TL1 I will explain you later. TE1, it is 0 for the first event. TE1, it is 0. The project has got just started in 0 days. Then TE3, to complete the third event, it would take 0 plus 4, 4 days. It is very simple. 1 to 2, 0 plus 2, 2 days. 1 to 4, 0 plus 3, 3 days. Till now it is clear. Now, at event 5, you might ask why it is 10. You have to see 3 to 5, the activity taken between 3 to 5 would take 6 for the activity between 3 to 5, and 4 days was for 3. 6 plus 4, 10. Write a comma. Then 1 to 2 it took 2 days, and 2 to 5 it is taking as 1 day. 2 plus 1, 3. 10 comma 3. Without the completion of the activity between 3 to 5, would the event 5 be entirely completed? Even if we complete 2 to 5, we cannot complete a event until and unless all the activities associated with it gets completed. So the activity between 3 to 5 is not yet completed. It would take 10 days to complete. Even though 2 to 5 is completed in 3 days, the project has to wait till 10 days. So TE5, it is 10 days. So now 5 to 6, it is 17 days. You are clear about it, I think so. 5 to 7, 10 plus 7, 17, comma. You can also write 4 to 6 also. It is 3 plus 5, 8. Without the completion of 5 to 6, the activity associated with 5 to 6, we cannot complete 4 to 6. So 5 to 6, 17 days. 17 is the answer. So TL6, 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 it is 17. You can directly write 17 because the latest finish time would be 17 days. The project cannot be delayed after that. Now, for finding TL at any node, you have to do a backward calculation. You might have seen these arrows. Arrows are moving forward towards the right side every time. Now just visualize the arrows moving towards left hand side. Reverse those arrows. Now 6 to 5, 6 to 5, 17. If you reverse the arrows, the duration 7 would be taken as minus. Just use that simple trick. 17 minus 7, 10 days. Only one arrow is merged in 5 if we reverse it. So you can directly write 10. In 3, only one arrow is merging here. So you can directly write 10 minus 6, it is 4. Then in 2, why it is 9? See, in 5 it was 10. In 2, 10 minus 1, it is 9. In 4, 17 minus 5, only one arrow is merging here. 17 minus 5, it is 12. Now why at TL it is 0 and not the maximum value? You might get confused. Why it is not the maximum value in this case? See, 3 to 1, 2 to 1 and 4 to 1 are different ways of completion. 3 to 1 you can complete in TL3 minus 4, means 4 minus 4, 0. Put a comma. Then 2 to 1, 9 minus 2, 7 days, comma. Then 4 to 1, 12 minus 3, 9 days. Okay. So 3 to 1 it will be 0, 2 to 1 it will be 7, and 4 to 1 it will be 9 days. In reverse calculation, while finding TL6, we will take the minimum value. The minimum value to complete. That is the latest start time. Minimum value should be taken when an event is merged by 3 activities. Okay, 3 to 1, 2 to 1 and 4 to 1, these are 3 activities associated Three arrows are towards 1. So while backward calculation will take the minimum value. Okay, and we can clearly see the critical path is 1, 3, 5 and 6. It has taken the maximum possible time. Okay, this was a diagram which we completed just now. We will draw a table determining the EST. Right, this EST is equal earliest start time. Write this. EST earliest start time. EFT earliest finish time. LST latest start time. LFT latest finish time. TF write as total float. FF free float. IF independent float. Okay. From the table it was given 1 to 2 it take 2 days, 1 to 3 4 days, 1 to 4 3 days and so on till 5 to 6 7 days. EST is nothing but the TE 1 2 3 4 till 6 what you have written. EST earliest start time, how much early an event can occur. 1 you have to see 1 to 2, just write 1 to 2 I and J. Event I is 1, the first is the I and second is J. When we write 1 to 2 I to J, I dash J. Okay, we have to consider only event I, that is 1 1 1 2 3 4 and 5. We need not to see 2 3 4, that is 1 to 2 we have to consider only 1 in EST. Earliest start time, the beginning of an activity. Okay, the beginning of an activity. So the beginning is 1 1, it took 0. EST column you write 0 wherever it is starting as 1. 1 to 2 0, 1 to 3 0, 1 to 4 is also 0. Then 2 to 5, 2 to 5, 2 is TE2 was 2, so directly write 2. TE3 was 4, so directly write 4. TE4 was 3, so directly write 3. TE5 was 10, so directly write 10. In EST column you have to see the beginning event, that is 1 to 2, the beginning event is 1, and write the TE in the diagram in EST column. If the earliest start time is known, the earliest finish time would be just earliest start time plus duration. Just EST plus the duration, EFT. EFT, write this formula, EFT is equal EST plus duration. That is 0 plus 2, 2 for 1 to 2, 1 to 3, it is 0 plus 4, 4, 1 to 4, it is 0 plus 3, 3, and so on. Till 5 to 6, it is 10 plus 7, 17. Now LST, latest start time, and LFT, latest finish time. LFT is TL, that we write in the diagram. LFT is TL in the diagram. Just you need to remember only these 2 points. EST is TE in diagram, LFT is TL in diagram. LFT, we have to see at what time the event has ended. So which one you will see in the activity? 1 to 2, 2. 2 has ended in 9. 1 to 3, 3 has ended in 4. 1 to 4, 4 has ended in 12. That is TL in every node. And so on. 5 to 6, 6 is ending at 17. Both 4 and 6, 6 is ending at 17, and 5 to 6, 6 is ending at 17. Okay? And LST is just LFT minus duration. You write this formula, LST is equal LFT minus duration. That is 9 minus 2, 7, 4 minus 4, 0, 12 minus 3, 9, 10 minus 1, 9, 10 minus 6, 4, 17 minus 5, 12, and 17 minus 7, it is 10. Okay. for the different activities. LFT, LST column you have to fill like LFT minus duration. Okay. Then total float. Total float is the latest start time minus the earliest start time. How the start times can be differed from each other. How early can a project event begin and how at latest by what time can a project begin. This is the total float. So for 1 to 2 total float is latest start minus earliest start, LST minus EST, that is 7 minus 0, it is 7. For 1 to 3 LST minus EST, 0 minus 0, 0. For 1 to 4 LST minus EST, 9 minus 0, it's 9, and so on till 5 to 6 LST minus EST, 10 minus 10, it is 0. Total float. You can see that total float at some points are 0 and some points are showing as numbers. You write this point that in the critical part the total float is 0. Write this is very important. Total float in a critical part is always 0. That is one, you can see where which events or which activities are 0. 1 to 3 it is 0 total float, then 3 to 5 it is 0, and 5 to 6 it is 0. You can clearly see 1 3 5 6 it is the critical part and their total float is 0. Okay. Now free float. What is free float? Write a formula first. Free float is equal total float. Total float minus, put a bracket, TL minus TE, close the bracket, at node J. 1 to 2, node J is 2. Okay. For 1 to TF was 7. So free float is equal 7 minus at 2. At 2, what was the difference between TL and TE? That is 9 minus 2. TL minus TE at 2. At node J, that is the free float. That is 9 minus 2, 7. That is 7 minus 7, 0. 1 to 3, total float was 0. 0 minus bracket TL minus TE at 3, that is 4 minus 4, 0. 0 minus 0, 0. Okay, I will show you where it is not 0. Okay, it is at number 2 to 5, activity 2 to 5. Okay, total float is 7. Put 7 minus TL minus TE at 5. TL minus TE at 5 is 10 minus 10, 0. TL minus TE at 5 is 0. 7 minus 0, it is 0. Okay. First of all, you have to just fill the table accordingly. It is very easy, not that hard. An independent float, same as free float, you write the formula. Independent float is equal total float minus bracket TL minus TE at node I. Simple. Free float was at node J, independent float is at node I. 1 to 2, node I is 1. So 1 to 2, TF 7. TL minus TE at 1, you have to see in independent float. TL minus TE at 1. TL minus TE at 1 is 0 minus 0, 0. Total float was 7. 7 minus 0, it will be 7. Then at 1 to 3, total float is 0. Okay. And at 1, 0 minus 0, it is 0. That is independent float at node 1 to 3. Okay, I think you are clear about it. You just need to practice this. I will show you the formulas, important formulas at the end of this video. You note those formulas and kindly proceed with this type of problems. These don't come in gate, but you need to be aware about it. Like the total float along a critical path is always 0. You just need to remember the total float along a critical path is always 0. These are the various concepts used. Kindly pause the video and write this table. Note down this table. Okay, if you have written in this table, T O T naught, that is given below. T naught is optimistic time. I am writing in short form in the table. T M is the most likely time. P is the pessimistic time, and P E is the expected time. Okay, what is optimistic time? Optimistic time is the minimum time taken for the completion of a project. How quickly and effectively, if all the processes are done very quickly and effectively, it is the optimistic time. The best possible time means the least time taken for the completion. Most likely time, it is the average time. Uh, we can both see the pros and cons of the activities, means there's might be some merits, some demerits, some advantages, some disadvantages. Considering all those, the time, most likely time means by that time it would be completed. This is the most likely time. TP is the pessimistic time. What do you mean by pessimistic time? Is that the maximum time taken, means everything has gone worse, everything has gone against what we have planned, and it had taken some days more than the expected date. Everything has gone wrong, and it is the maximum possible time taken when everything has gone wrong, and we have completed the project. So we can take a expected time. Okay, TE expected time from these three times. Hence part is probabilistic. We can combine these three to take an expected time. Okay, so TE is T naught in column 5. TE is T naught that are given in red font. T naught plus 4TM plus TP whole divided by 6. This is the formula for expected time. For variance, the formula is TP, pessimistic time, minus T naught, optimistic time, whole divided by 6 whole square. Okay, these are the just two formulas. I think you have written the table. So moving forward, it was the same diagram that I took to make you understand the CPM network. Okay, so you have the diagram, you can just write it down. In part problems, there are basically calculations like what is the probability of completing 6 days earlier than the expected date. What is the probability of completing in the 21st day? Okay, so there would be a table given Z and P. Okay, Z, there are values like 0 0.5, 0 0.67, 1, 1.33, 2.00, and for zero point 0.5, for Z is equal 0.5, P is 0.19, and so on. For 2, Z is equal to P is 0.4772. These are very simple things you need to understand. Just write this table also. Pause the video and write this table. Okay, what is the solution? Z. First of all, Z. Z is due date minus expected date divided by whole divided by root over variance. Write the formula: due date minus expected date whole divided by variance. Here TS is 11 days. How? Because TE, if we add TE in the entire column, we got 17 days. And in the question, it was asked that 6 days earlier than the expected date. So 17 minus 6, it was 11. So Z is equal 11 minus due date is 11 minus expected date was 17 divided by 3. So that became minus 2. So we will write PTS is equal 11. Means if TS is equal 11 days, we will write PZ is equal minus 2. For TS is equal 11 days, Z was minus 2. You get it? So the formula is zero point 0.5 minus phi of 2.00. Phi of 2.00. Now 0.5 minus 0.4772. For 2.00 in the table, it was for Z is equal to 2.00, it was 0.4772. So 0.5 minus 0.4772. That 0.5 came from the minimum value that is seen in the table. Always you will be given a table and the minimum value of Z you have to just write in front, and if Z is equal minus 2 in this case, minus phi 2, if Z is equal plus was only 2, then you have to write plus phi 2. So in this case, 0.5 minus 0.4772 is 0.0228, that is equal to 2.28%. That is, there is a probability of 2.28% only to complete the project in 11 days. If the expected date is 17 days for the completion of a project, if we want to complete it in 11 days, that is 6 days earlier, the probability of completion is 2.28. That is pretty low. I will show you if TS is 21 days. Okay? If the expected date means if expected date of completion is 17 days, but we want to complete it in 21 days after 4 days, then Z will be due date, that is 21 days, minus expected was 17, divide by 3, Z is equal 1.33. So similarly, PTS is equal 21. At 21, Z was 1.33. PZ is equal 1.33. So I told you to write 0.5 plus. Here plus because 1.33 was plus. So plus phi 1.33. So 0.5 plus 0.4082. That is 0.9082. That is 90.82%. That is very high percent of completion of the project in that date. So there are some miscellaneous problems also, we will discuss it. Dummy activity with the help of a network diagram. You kindly write this table, note down this table. Then I will show you the dummy activity with the help of a network diagram. Okay. Moving forward, in this table, 1 to 2 activity A, if 1 to 2 activity A, first was activity A, it was not preceded by anything. Activity B was also not preceded by anything. So these are the beginning activities. Okay, if it is not preceded by anything, directly from 1 you have to put an arrow. A 1 to 2, B 1 to 3. Okay, then C was preceded by A. Okay, you can clearly see C is preceded by A. C comes after A. Then D. D was preceded by B and C. You might ask a question, why I have given it towards 4 to 3? Why I have added a 4 to 3 arrow? That is the dummy arrow. That dummy arrow won't consume any time. time is equal 0 days, so we don't write anything, it is just for reference. Okay, D was preceded by B and C, so we put a dummy towards B and we write D. You might also ask why we have not put an arrow in the reverse direction. B to C means 3 to 4. Why the arrow is not from 3 to 4? It is just because in the table you can see another activity E is preceded only by C. So if we put a arrow here and write D and E both, then E would be preceded by both B and C. That was not true. E is only preceded by C and D is preceded by C and B. You get it? D was preceded by C and B and E was preceded by C. In the table you need to see whether an activity is preceded, if an activity is preceded by only one activity, let E was preceded by C in the first case, and also D was preceded by C and B. C came twice, so you have to mark an arrow towards the other one which has no extra successor. Means C has two successors, E and D, but B has only one successor, D. So the arrow should be towards the one which has only one successor. Okay, then E was preceded by C, and again F is preceded by E and D. F is preceded by E and D. I have given the arrow towards this, but the arrow is not towards D. Why? Because Z was only preceded by D. If I would have given the arrow from 6 to 5, it would have not followed the table. Like 6 to 5, if the arrow was towards 5, then Z would have been preceded by E and D. That was not true. Z was only preceded by D, and hence it is the final event. We have written it as 5 to 7. Okay, you are clear, I think. Here TE1 it is 0. I will not explain it anymore because I think you are almost clear about it. 1 to 2, 0 plus 1, T2. It is 2 to 4, only 1 is merging, 5 days. Then it is 5 days because 1 to 2 it took 2 days, comma, another dummy is also there. It does not have any time, it has 0, but 5 plus 0, it's 5 here. At 4 it was 5 and dummy activity has 0, so 5 plus 0, 5, that is greater than 2. 1 to 3 it is 2, but 4 to 3 it was 5, so we'll write 5 here. Then at 5 it is 7, 5 plus 2 straight 7. Then at 6 it is 10. How? 4 to 6 it is 5 plus 5, 10, and 5 to 6 it is 5, it is 7 plus 0, 7. 10 comma 7, which is greater? 10. So we'll directly write 10. In 7 it is 10 plus 2, 12, and from 6 to 7 it is 10 plus 2, 12, and from 5 to 6 it is 7 plus 1, 12. Which one is greater? 7 plus 1, 8. Which one is greater? 12. We'll write TE7 12 and TL7 it is obviously 12. Now reverse all the arrows. Reverse all the arrows. And first of all we'll get the critical part as 1, 2, 4, 6, 7. This is the critical part. Now visualize the arrows in reverse direction. Okay? TL6, only one arrow is towards it. TL6. Okay? 12 minus 2 it's 10. In the critical path, always TL is equal to TE. So in critical path, you can directly write TL, TE, same values. Always there will be the same values. Now at 5, why it is 10? Okay, reverse the arrow. Originally the arrow was from 5 to 6. Now put the arrow from 6 to 5. Okay, 6 to 5. Now 12 minus 2 at 6 it was 10. Okay, 6 it was 10, and from 5 to 7, 12 minus 1 it is 11. 10 and 11, which one is least? 10. In reverse, I have told you to write the list. 5 is 10, then it is 8. How it is 8? 5 to 3, if we reverse it, 5 to 3, 10 minus 2, it is 8. Okay, and it is the only way which 3 is completed, in which 3 is completed. Here the important formulas are given for free float and independent float that I have explained you earlier. Kindly write these formulas and practice the problem, and you would be able to easily verify the free float, independent float and total float in a CPM problem. So thanks for watching the video. Stay connected with us and we will provide you good materials for GATE examinations. Thank you.